Welcome to our next lesson that explores basic Java features for developing Android apps, which focuses on writing and calling your own methods. After completing this lesson, you will understand why methods are such an important concept in Java programming. You will also know how to define a method and how to call it, as well as understand what actually happens when a method is called. Moreover, you will recognize how to declare parameters for a method and how parameters are passed to that method. In addition, you will be able to overload methods. Finally, you will learn how to return a value from a method and how to specify the value that will be returned. In this lesson, we are going to learn about writing our own methods. Before doing so, let's answer the question of why we need methods. Remember from an earlier lecture that an algorithm is a precise, unambiguous, step-by-step process for accomplishing a task. Here's a simplified example algorithm for building a Lego house. And here we see our algorithm converted into Java code. So far so good, right? Well, there is one problem in that our algorithm does not have any reusable parts. For instance, consider the task of building a two-story Lego house. If we look at our Java version, we see that we have several identical lines of code that are repeated. This redundant code is very poor programming style, since if we ever wanted to make a change to the building of the walls or windows, we would have to make those changes in two separate yet identical places. This leads to errors, since it is common for someone to make a change in one spot but forget to make the change in the other spot. To solve this, Java allows us to define methods. A method is simply a group of statements to which we give a name. We can then use the name to execute the statements within the method. When we define methods, it is like adding new commands to the Java language that we can use. There are two types of methods in the Java language: static methods and member methods. Static methods are not associated with objects, but are rather independent helper functions. We have seen many examples of static methods in the math class and the character class. In contrast, member methods are associated with some object type and must be invoked on an object using dot notation. The methods of the string class, which operate on string objects, are all member methods. In this lesson, we will focus on static methods, whereas member methods will be addressed in more detail in a later module in this MOOC. Here is the syntax that you use when you declare a static method. It has several parts that we will go over one at a time. The keyword public specifies that everyone can call this method. All the methods that we create in this lesson will be public. In a future lesson, you will learn about private methods. The static keyword declares this method as a static method rather than a member method. If you were creating a member method, you would simply remove the word static. Next, you specify the type of the value that the method will be returning to the caller. This can be any known data type. If the method does not return a value, you specify void as the return type. Next, you specify the name that you want to call the method. Like other names in Java, it must follow the rules for an identifier. As always, the name should be descriptive of what the method will do for the user. Next is the parameter list that specifies the values that will be received when the method is called. We will address the details of the parameter list a bit later. If the method does not have any parameters, then the parameter list will be empty. Next come all the statements that you want to have executed, enclosed in the set of curly braces. When the method is called, these are the statements that will be executed one after another. So every method is made up of a header and a body. The method header is everything that is needed to be known to call the method. The method body is the code that will be executed when the method is called. Here's an example of a very simple method. This method does not return a value and does not receive any parameters, and it simply prints some text to the display. To call a static method, you simply reference the method name and place the parameters inside the parentheses. If the method does not take any parameters, the parentheses are empty. For example, we can call the welcome message method that we defined on the previous slide, and each time we do so, the same message will be printed on the display. When you call a method, your program will temporarily pause executing the calling method and branch to the called method and begin executing it. When the called method is done executing, the program will return to the point of the call and continue execution where it left off. This allows one method to call another method, which calls another method, which calls another method, etc., without us getting confused, because every called method returns to the point from where it was called. For example, consider this snippet of code that prints the first 2 days from the song, The 12 Days of Christmas. The method 12 days calls the method day 1, and then the method day 2. The method day 1 simply prints a line of text. The method day 2 prints a line of text and then calls the method day 1, and the output is shown below. Here's a graphical representation of what is happening. When the method 12 days calls day 1, we start executing that method, and when it is done, we return to the point of the call, at which point we call day 2 and start executing that method, which in turn makes its own call to day 1, and we start executing day 1 method again. But this time, when the day 1 method is done, we return to the point of its call, which is in the day 2 method, which then ends its execution, and we return to the 12 days method. So it is good to define static methods whenever we have a group of statements that are related structurally, such as building a wall in our Lego house, or to eliminate redundancy if we have statements that are repeated in several places in our code. Next, we will discuss method parameters. A parameter is simply a value that a caller wants to pass into a method that is being called. We've already seen how this works when we discussed the math class and all its static methods. A parameter is a special type of variable that is declared in the method header and will be given a value each time the method is called. When you declare that a method accepts a parameter, then calling that method requires that you provide a value for that parameter. When declaring parameters in a parameter list, you must provide both a type and a name, similar to declaring variables. Here's a simple example of a method which has a parameter called name, which is of type string. Whenever someone wants to call this method, they must provide a string value. When calling a method that expects a parameter, you must supply a value, and this value will be used to initialize the parameter before the method begins execution. Here we see a simple call to the say hello method where we pass the string Doug. You can specify methods that receive multiple parameters by separating the parameters with commas. You must specify the type and name of each parameter. And when you call such a method, you must apply a value for each parameter. The values at the call are matched to the parameters of the method by position. The first value to the first parameter, the second value to the second parameter, etc. Java allows you to define methods that have the same name as long as the parameter lists of the two methods are different and can distinguish the two methods. We call this overloading. When methods are overloaded, the compiler will look at the number and types of the parameters to determine which method gets called. We have actually seen an example of overloading earlier with the string class that has two different substring methods. One that has both a starting position and an ending position, and the other that only has a starting position. Here's a useful example of overloading where we want to print the average of some values. One method will print the average of 2 integers, while the next one prints the average of 3 integers, and the last one handles 2 doubles. All 3 methods do the same type of thing, so it's convenient that they share the same name. At this point, it is appropriate to introduce the concept of scope. The scope of a variable is the portion of the code in which the variable exists and can be referenced. In Java, the scope of a variable is from the point of its declaration to the end of the enclosing curly braces. In the sample code shown, the scope of the variable x is from its declaration to the end of the method named example, while the scope of the variable I is only the 2 lines of code in the inner curly braces. The scope of a method parameter is the entire method in which it is declared. Now, variables that do not have overlapping scopes can use the same name. This allows all our overloaded print average methods to also have parameters that reuse the same name. But Java does not allow variables with overlapping scopes to have the same name. When a Java method is called, its parameters receive copies of the values passed in. This is known as call by value. In this example, we have a method named double that receives an integer parameter. When we call it with 3, the method receives a copy of the 3 and prints the value 6. When we call it with x, the value of x is copied and the method prints the value 10. Note that the variable x was not sent to the method, but rather a copy of its value. Thus, if the called method changes the parameter, that change will not affect the caller, since the method only receives a copy. In the example shown, the method funny doubles the value of its parameter before printing it, but doing so does not affect the caller's variable x, since only a copy of x's value was sent to the method. Note that due to scoping rules, the variable x in the method process is a different entity than the parameter x in the method funny. Next, we will discuss methods that return values. We have already seen methods that return values when we discussed the math class. All the methods in the math class return values to us when we called them. Now we're going to see how to create our own methods that return values. If a method is going to return a value to the caller, you need to specify that in the method header. This is done by simply replacing the keyword void with the data type of the value being returned. Here's an example of a method that returns the value that is 3 times the parameter it receives. Note that the method header specifies that a double value is being returned to the caller. Now, somewhere in the method body, we must specify the value which we want to have returned to the caller. We use the return statement to accomplish that. Once we learn about control flow statements in the next module of this MOOC, it will be possible to have multiple return statements in the body of a method, though it is often preferred to have only a single return statement at the bottom of the method. But it is important to understand that when a return statement is executed, control returns to the caller immediately. A return statement always ends the execution of a method. Here are 2 examples of methods that return values. The first computes the volume of a sphere given its radius, and the second rounds a floating point value to 2 decimal places. And here we see the same methods that have been tidied up a bit by eliminating the local variables and simply having the return statement compute the value that is to be returned. On a closing note, this lesson has focused on static methods that are usually helper methods that are not part of an object class. Again, object class will be seen in a later session. And all the methods would work if the out object we are using for printing were globally defined, like the system.out object used in desktop computing. Unfortunately, in the Android world in which we are operating in this introductory class on Java, the out object is not global, but is rather a data member of the logic class in which we are currently doing all of our work. Thus, if you have a method that needs to access the out object from printing to the screen, you will need to remove the static keyword from the method header for the method to work correctly. If your helper methods simply take in parameters and return values and do not print anything to the out object, then they can remain as static methods. This lesson introduced you to writing Java methods. Now that you have completed this lesson, you should understand the concept of a method and why methods are so important in Java programming. You should also know how to define a method and how it is called, as well as understand what actually happens when a method is called. Moreover, you should recognize how to declare parameters for a method and how parameters are passed to that method. In addition, you should be able to overload methods. Finally, you should know how to return a value from a method and how to specify the value that will be returned.